Okay, so this is the second part of your notes. So you had points, lines, and planes, and naming, and then you had segment addition. So these are the examples for segment addition. All right, so here we have a segment that is broken into two smaller segments as well. So this is how the segment addition postulate works. It shows that the length of AB, so from this dot to this dot, plus the length of BC from point B to point C equals the length of the whole thing, which is segment AC. Okay, so we're just talking about the lengths, so we don't need to have the segment symbol above these because distance is labeled with just the 2 points together. Okay, so we have the distance between A and B plus the distance between B and C equals the distance between AC. Okay, so these are pretty simple. So if I told you AB was length 5 and BC was length 7, all we have to do is plug those numbers into the equation to figure out what AC is. So AB is 5, BC is 7, so the whole thing is 12. Okay, so you don't have to actually use this equation necessarily. You can just know that if you add the two smaller pieces together, you get the bigger piece. Okay, so if I told you that PQ was 13 and QR was 11, then what would we know that PR is? PR would be, add those together, 13 plus 11 is 24. Okay, so super simple, just add them together to get the long length. Okay, so then we could have examples where we know the longer length and one of the smaller lengths. So let's just say they tell us that JL is 16 and JK is 4. Okay, so we know that these two add together to give you the longer length. So instead of adding in this case, we're going to subtract. So we take the longer length minus the shorter length, and that will give us the other length that we're missing. Okay, so we would be looking for JL, and the distance between KL, the distance between K and L would be 12, because 16 minus 4 is 12. All right, just another quick one of those. Okay, so say they say MO is 41 and NO is 13. Okay, so we know this is 13 and the whole thing is 41. So again, we subtract. So we have 41 minus 13, which gives us 28. So we know that length MN is 28. Okay, you can always double check these by adding. Make sure your 28 plus your 13 gives you your 41, which it does. And up here, make sure that 12 plus 4 is 16, which it does. All right, so then they can add equations into it. So this makes it a little trickier, but it's still pretty simple. If you're good at solving equations, you'll be fine. If you need some review on solving equations, let me know so I can help you out. All right, so here's our first example. All right, so let's say that they give us the equation x plus 4 for the length of AB and the equation 7x minus 3 for the length of BC. Okay, then they also have to tell us how long AC is. So AC is 65. Okay, so this is all the pieces of information they would give you, and then they would ask you to find the length of AB and the length of BC. Okay, so again, we know that you add these two together to get this one. So we are going to combine that. X plus 4 plus 7x minus 3 equals 65. So that's how you set up the equation, and then you're just going to solve equations like you learned in Algebra 1. So we're going to combine like terms on the left. X plus 7x is 8x, and 4 minus 3 is 1. Okay, now we're still solving for x, so we have to move all numbers to one side. So we're going to subtract 1 from both sides, and we get 8x equals 64. Okay, and then our last step is to divide by the number beside the x. So we're going to divide both sides by 8, and we get x equals 8. Okay, so we found what x equals, but we still want to figure out the lengths of AB and BC. Okay, so what do? We plug in 8 for x. So if we're solving for length AB, we're going to plug 8 in for x. So we have 8 plus 4. So we know our length of AB is 12. Okay, if we're doing the same thing for BC, we plug in 8 for x. So we have 7 times 8 minus 3. 7 times 8 is 56, and we subtract 3 from that to get 53. Okay, and then a quick check. We want to add 53 and 12 together to make sure we get that 65 that they told us AC was. So 53 plus 12 is 65, so we're good to go. Okay, so your steps, you want to plug it in for the AB plus BC equals AC equation, solve for your X. Once you get your X, you still have to find the lengths of the missing segments. So we did that by plugging in our 8 for X in both of their equations. All right, here is another example to use. Let me get another piece of paper. All right, so they're going to tell us that the equation for PQ is 3x minus 5, and QR is length 14, and that PR is 5x minus 9. Okay, so they give us the smaller pieces and the bigger piece. Again, we know we add these two together to get the bigger one. So we're going to have 3x minus 5 plus 14 equals 5x minus 9. Okay, and then we're just going to solve for x again. So on this side, we got to see if we can combine like terms first, which we can. So we have the 3x, and negative 5 plus 14 is positive 9. And we're going to copy that right side. Nothing to combine over there. So now we want to move all the x's to one side, all the numbers to the other. So I'm going to subtract 3x from both sides. And we're going to get 9 equals 2x minus 9. Okay, so we had both of our x's on the right, so we want to move our numbers to the left. So to move negative 9 over to the left, we want to add 9 to both sides. Okay, 18 equals 2x. Last step, divide both sides by 2, and we get x equals 9. Okay, so once we find what x is, we still have to find these missing distances. So we know that QR is 14, but we need to find PQ. So for PQ, we got to plug in 9 for x. We get 3 times 9 is 27. Subtract 5, and we get 22. Okay, for PR, we have 5 times our x, which is 9, minus 9. So we have 9 times 5, which is 45, and we want to subtract 9 from that, and we get 36. Okay, so remember our last step is to make sure that our two small segments add together to give our bigger one. So we have PQ was length 22, QR is 14, and PR is 36. Is 22 plus 14 36? Yes, so we got that one right. All right, so you guys can work on your assignments now, and if you have any questions, just let me know.